What are the initial conditions on a differential equation? Consider a very simple case, y prime equals to 1, for example. This is telling us that y is a function of t, right, with derivative or growth rate equals to 1. If you solve a integration, you will get that y is equals to integral of 1 is t plus constant. This is a family of curves, right, where here is t and here is y. Actually, it's a family of lines. Here we have y equals to t, and here we have y equals to t plus 1, assuming this is 1. And here we have y equals to t minus 1, assuming that's the point minus 1, and so on. So these solutions are a family of parallel curves because all of them have the same slope. They grow at the same time. They are all parallel. So now if we add an initial condition, something like y of 1 equals to 7, this means simply that of all these parallel curves, choose the one that at time 1 goes through 7. Through 7. This means when t is equals to 1, y is equals to 7. As y is t plus c, 7 has to be 1 plus c. So c has to be 6 and y is t plus 6. So the initial condition here gives to determine which one of these curves is the one satisfying this. Because the differential equation, the only thing it does is simply gives us a family of parallel curves. So let's consider a slightly more complicated problem as we have seen in class. So this is a linear equation with constant coefficients, homogeneous. And to solve this, as we have seen in class, you make the characteristic equation a squared minus 7a plus 12 equals to 0, from which you get a is equals to 4 and 3. Hence, we have what I have called in class basic solutions of this equation, given by y1 is e to the 4t and y2 is e to the 3t. And the general solution of this equation is a combination of the basic solution. So will be yh for homogeneous, a constant to be found e to the 4t plus another constant e to the 3t. Now, what we need to find the solution of this problem are the values of a and b. So sometimes these values are easy in some problems, like they give you something like y of 0 and y prime of 0. But in this case, we have a little bit different, which is y of 0 is 10 and y of 1 is equals to 20. Observe that the equation has the highest derivative of this equation is the second derivative, so this say is degree 2, and we have two initial conditions. So we can determine the solution properly, fully. So what is it? So we have 40 equals to 0, y of t, y of 0 is a, number a to be found, e to the 0 plus b e to the 0. Now e to the 0 is 1, so that's equals to a plus b, and that has to be equals to 10. Now for the 1 is a e to the 4 plus b e cubed, so this equals to 20. Nothing to be scared of here. A to the 4 and e to the 3 are two numbers that you can find in your calculator. But they're numbers. So this is to find a and b. We must solve this easy solution. A plus b equals 10. And e to the 4, which is a number, a plus e to the 3, b equals to 20. The 4 and e to the 3 are numbers. E to the 4 is approximately 54.6 and e to the 3 is approximately 20.09. But we don't need this. We can operate like numbers. We multiplied the first equation by e to the 3. So we have e to the 3, 20 something a plus e to the 3 times b is 10 times e to the 3. And let me separate this here. And a to the 4a plus a to the 3b equals to 20. I put a to the 3 on the right hand side, usually e to the 3 times 10. I prefer to write 10 times e to the 3, but doesn't matter. Now we subtract the second equation minus the first, and we get e to the 4a minus e to the 3a, and e to the 3b, e to the 3b goes off, 20 minus 10 times e to the 3. Let me make this clear. So here we take common factor a, e to the 4 minus e to the 3, times a equals 20 minus 10 times e to the 3. Again, e to the 4 minus e to the 3 is a number, will be 54 minus 20 around 34. We can move it to the other side and we can get simply that a is equals to 20 minus 10 e to the 3 divided by e to the 4 minus e to the 3. Now, in order to simplify things, we'll take a calculator and we compute. This is approximately minus 5.24. So to get b, we use any of the equations. We have a plus b is equals to 10. So minus 5.24 plus b is 10. And b is approximately 15.24. And your solution is homogeneous a, which is minus 5.24 e to the 4t plus b 15.24 e to the 3t. And that's it. There's nothing else to be scared of. E to the 4 is a number. E to the 3 is a number. So you can handle like numbers. If you prefer, here where you have a plus b equals to 10, and e to the 4a plus e to the 3b equals to 20, you could have used your calculator and you could have computed what is a to the 4 and a to the 3, and you got a plus b equals to 10, and 54.6a plus 20.09b equals to 20, and you could have solved for a and b as before. As these values are approximate, maybe the solution you get is not exactly the solution I got above, but it's an approximation, so it's good enough. Nothing to be scared of. You use the calculator there. You can use the calculator, for example, here. I have used the calculator. It doesn't matter. The point is that e to the 4 and e to the 3 are numbers and nothing to be scared of.